Section 7.2, and we're going to talk about the surface area and volume of prisms. And we talked a little bit in the last class about prisms. We talked about rectangular prisms. Today we're going to make it more general, and we're going to talk about any kind of prism, and we'll point out where things overlap and where they don't. Well, the first thing I want to do is remember what is important about a prism. What makes a shape a prism? So what do we have to have in order for a shape to be a prism? Anybody? Can you help us out, Aaron? What kind of shape is a prism? What did we say was important about a prism? Anything you know about a prism? Okay, it has to be a 3D shape. So it's a 3D shape. That got us started. What else is important about a prism? We had some important facts. So if we look at a shape, how can we figure out it's a prism? One, it has to be 3D. What's another fact about a prism? Got one? Okay, that kind of was the essential information that we were looking for. So we said it was 3D. So a polyhedron means it's 3D. So we could say that it's a polyhedron. We're being a little more precise. And the really important, the essential pieces of information are that it has two congruent parallel bases. The bases of the prisms, the base of the prism is the key. That's how we figure out its name. That's how we're going to figure out lots of things by working with the base of the prism. So we have to remember it has to have two congruent parallel bases. Those are the important things. What about the sides? The sides of a prism are what kind of shape? Sides of the prism are polygons. And we can be a little more specific even. What kind of polygons are the sides of prisms? Rectangles. If we have a right prism, they're rectangles or parallelograms. So we have two congruent parallel bases. That's how we figure out what kind of prism we have, and the sides are rectangles or parallelograms. And we're going to come back to the sides being rectangles for a right prism in just a second. All right, so there's our essential information. We need one other piece of information about a prism, and then we can start talking about our formulas. So let me draw one here. So we're going to draw a triangular prism, and I'm going to draw it so. So here's our nice triangular prism. I know these should be dotted back here also, but we're going to draw in a segment from one base to the other base. So this is our base. And I'm going to draw in a segment that is perpendicular to each base. and goes from one base to the other base. So this makes a 90-degree angle with each base. This segment we are going to call the height. This is how we find the height. We'll also call it, you'll also see it called the altitude. And the height, we find the height, just like we talked about with parallelograms and with triangles, the height is makes a 90-degree angle and goes between the bases. So it's a segment that makes a 90-degree angle with each base and goes between. That's how we find the height of a prism. Now this, I talked earlier about how we're going to use words to mean several different things. So we have a height of a prism. Well, on the base is a triangle. To find the area of a triangle, we also talk about the height of the triangle. We also talk about the base of a triangle. So we're using the word height and we're using the word base to refer to several different things. It's going to be really important to keep those things straight and understand what we're talking about when we're talking about the height of the prism versus the height of the base. The base of the prism versus the base of the triangle that makes up the base of the prism. So we're using words to mean different things, different parts of the prism, but we're using the same word. So it's going to be really important to keep those straight. All right. So now we're ready for our formula. Before we go on, does anybody have any questions about the height of a prism? We're going at a 90-degree angle between the two bases, and that's how we measure our height. Okay, so our surface area. The surface area of a right prism. And we came up with a formula for the surface area the other day. The formula that we came up with the other day, the one that we used in our opener, is only for rectangular prisms. That one only works for rectangular prisms. This formula that we're going to talk about now works for any right prism. We're going to say the surface area, and you'll see it written as a capital S. We're going to use SA to mean surface area. Our surface area is HP plus 2B. And then we're going to talk about what all of these mean. H is the height of the prism. So that's the piece that we just talked about. P is the perimeter of the base. So we have to know what the base is, and we need the perimeter of the base. And capital B, big B, is the area of the base. And our units for surface area are units squared. We're talking about an area, so our units are going to be units squared. So we need all of these pieces of information to find the surface area of a prism. We need the height of the prism, we need the perimeter of the base, and we need the area of the base. And we'll do a couple of examples in just a second, but I just want to point out that we're using height to talk about a couple of different things. The perimeter, one big mistake that students make a lot is they think that the perimeter is the perimeter of the entire shape. So they want to start adding up all the sides. The perimeter is always the perimeter of the base. And capital B is the area of the base. So we have to figure out the base. The base is the key. And we'll come, once we talk about surface area and volume, we'll come back to this formula and talk about where it comes from. All right, any questions on our formula? So again, this formula will work for any right prism. The other formula that we talked about is only for rectangular prisms. So we can use this formula for any prism. The other formula was only for rectangular prisms. So let's look at an example of using this formula. So we want to find the surface area. And we have a prism with a height of 7 centimeters, and our base, and this is our base. So we have this triangle, and this is 3 centimeters, 5 centimeters, and 2.5 centimeters. So before we calculate, what kind of prism, what would we call this prism? What kind of prism would this be? What would you say, Stephen? A right triangular prism. So our base is a triangle, a right triangle, so we could say that the prism is a right triangular prism. We name the prism by the shape of its base. All right, so we need several pieces of information to, guys, let's put the electronics away, please. We need several pieces of information to use our formula. So what's the first piece of information that we need? What are we going to have to find to use our surface area formula? The height. So we need the height. So what's the height in this particular problem? So the height in our formula is the height of the prism. So our height is going to be 7 centimeters. If I drew a quick picture of this prism that we're talking about, and this can sometimes help you solve the problem, this would be the picture of my prism. So it would look like this, and this segment is 7 centimeters. So this would be a quick sketch. So the height is 7 centimeters. What else do we need for our formula? We need the perimeter of the base. Perimeter of the base. How are we going to find the perimeter of the base? Add up all the sides. We know all the sides of the base, right? So our perimeter is just going to be 3 plus 5 plus 2.5, which gives me 10.5 centimeters. What else do we need for our formula? We need the area of the base, capital B. What's the area of the base of this prism? How are we going to find the area of the base? Base, there we use the word base again. Base times height divided by 2. So what's the base of this triangle? 2.5. We can say that's the base of the triangle. The height of the triangle? 3. We're going to divide that by 2. And when we calculate that out, I get 3.75. So the area of the base is 3.75 centimeters squared. Now we can calculate our surface area. Our surface area is the height, 7, times the perimeter of the base, 10.5, plus 2 times the area of the base, 2 times 3.75. And then I just calculate that all out. So I get 10.5 times 7 is 73.5. And I add 2 times 3.75, which is 7.5. I add those together, and I get a nice round number. Our surface area equals 81 square centimeters. So the way I solved this problem, I went through a lot of steps, but this is the kind of work you would need to do to solve a problem having to do with surface area of a prism. You need to figure out the height. You need to figure out the perimeter of the base. You need to figure out the area of the base. All these pieces of information we need to find our surface area, and then plug our numbers into our formula and calculate. If it helps, draw a little picture like so. And remember that we're using height to talk about the height of the prism, the height of the base. We're using the word base to talk about the base of the prism and the base of the shape that makes up the base of the prism. We're using the words, lots of words to mean a couple different things. So questions on that example? All right, let's look at another one. Calculating with surface area. So this one, we have a regular hexagonal prism. So before I write anything else, what does this tell me about the prism? Hexagon, what part's a hexagon? The base is a hexagon. So our base is a hexagon. And regular means what about the hexagon? What is it? All the sides are the same. So we have a regular hexagon for a base. All right, so our dimensions. The height is 12 centimeters. The apothem is 10 square root 3 centimeters. And the base side length is 20 centimeters. And we want the surface area. All right, so we need to find some pieces of information to plug into our formula. So what's one piece of information that we need? What do we need, Tanner? The height. Okay, so that's one piece. So we know that the height. What does the problem tell us the height is? 12 centimeters. So that one's easy. We don't have to figure anything out. Sometimes we have to figure out the height. We need, what other piece of information do we need? Perimeter of the base. We need the perimeter of the base. Well, the base is a hexagon. So how do we find the perimeter of that hexagon? Add all the sides. So if we were going to do that, Jonas, how would we go about finding the perimeter of the base? What's a hexagon? How many sides does it have? 6. Okay, so we have 6 sides. And how long is each side? 20. So to find our perimeter, add them all up. So we have 6 times 20. We have 6 of them. Each one's 20. So our perimeter of our base is 120 centimeters. What other piece of information do we need for our formula? Area of the base. We need capital B. So we need to find the area of this regular hexagon. How do we find the area of a regular hexagon, Brody?
What?
How do we find the area of a regular hexagon?
Is it base times height by 2? Is it something like that?
Yeah, it's something like that. Not base and height, but the apothem times the perimeter divided by 2. So, right idea. So the area of our base is the apothem times the perimeter divided by 2. Here's one of our area formulas from chapter 5 that we have to use now to find the surface area of this shape. But we have all the information we need for this formula, don't we? What's our apothem? 10 square root 3. It gives it to us. What's the perimeter of the base? We just figured it out. It's 120. and we're going to divide that by 2. And we'll do this as a decimal. So I'm just going to put this in my calculator, multiply these all out, divide by 2, and this comes out to be 1039.23 centimeters squared. I round to the 100. Now we have everything we need to plug into our formula. So our surface area equals the height, 12, times the perimeter of the base, times 120, plus 2 times the area of the base, 2 times 1039.23. I plug this all into my calculator, add it together, and I get 3518.46 centimeters squared for my surface area. And remember, when we do these problems, when we're adding here, we're going to multiply this, and then add. You don't multiply this and then add and then multiply. You have to multiply this, and then add the 2 parts together. So questions on that example? So surface area problems involve finding all these pieces of information to use our formula. And that those pieces of information use what we learned in chapter 5, because we have to find the area of the base. We might have to find the apothem of the hexagon in order to figure it out, using what we know about regular hexagons. So, and we'll come back to this formula and talk about where it comes from in just a little bit. But next we want to talk about volume. So any question before we move on? Okay. So the volume of any prism so this formula will work for any prism. The volume, and we use a V, equals capital B times H. B equals the area of the base, and height equals the height of the prism. And our units are units cubed for volume, always. So this formula will work for any prism. And again, the base is the key. We need to find the area of the base. The other day we talked about a rectangular prism. So if I draw a quick rectangular prism here, I want to show you how these two formulas are connected. So we said L, W, and H. We said the volume of this rectangular prism was L times W times H. Well, if I look at this rectangular prism, like so, the area of the base is this rectangle. The area of the base is the length times the width. That gives us the area of the base. So this length times width is our capital B. So these two formulas are really saying the same thing. L times W is the area of the base of this rectangular prism, and we multiply it by the height. So our volume is the area of the base times the height. So again, the base is the key. Questions on our formulas? All right, let's look at an example calculating with this, and then we'll go back to the surface area formula quickly and talk about where it comes from. So we want the volume of a right triangular prism where the height is 10 centimeters, and we're going to use the same base as before. So we found the surface area of a prism that was kind of like this, but we're going to use, this one's going to have the same base. So we have 5 centimeters, we have 3 centimeters, and 2.5 centimeters. So we want to find the volume, and this is a right triangle. So before we solve this problem, let me ask you this question: what could we do? Say in order to find the area of the base, we have to know the sides of the triangle. What if we didn't have this side of this triangle? We can't find the area of the base without that side of the triangle. What could we do if we were given a problem like this? You have any ideas, Ian?
No.
Well, what kind of triangle is this? Not necessarily, but this is a 90-degree angle, right? So it's a right triangle. What always works on right triangles? A squared plus b squared equals c squared. So if we didn't know this side, we could use the Pythagorean theorem to figure out this side of the triangle. So sometimes you have to do that to figure out your problem. You might have to do some additional work just to get the parts that you need to plug into your formula. So in this example, we could use the Pythagorean theorem on the base. All right, so our volume equals the area of the base times the height. So we need a couple pieces of information. How do we find the area of the base here? Base times height divided by 2. And Tanner, what's our base and our height of our triangle here? 2.5. And the height of the triangle? 3. 10 is the height of the prism. So got to keep those straight. So 2.5 times 3 divided by 2. And we calculated that out before, didn't we?
Yeah.
And that comes out to what? 3.75 centimeters squared. We need our height. Well, we know our height is 10, so our volume is 3.75 times 10, and I get 37.5 centimeters cubed for my volume. Any questions on that example? The height of which height? Oh, it tells us the height of the prism is 10 centimeters. So in the problem they gave it to us. If this problem didn't give you the height, you wouldn't be able to find the volume. They'd have to give you some other kind of information to figure out the height. But yeah, that is a key piece of information to find the volume. So they might have some other information in the problem that would let you find the height, but you have to be able to find it to do the problem. All right. Let's look quickly at the surface area formula and talk about where it comes from. Part of it can be helpful because we're going to talk about nets really quickly. So what I'm going to do to talk about this formula a little more is I'm going to take this, I'll draw a triangular prism. So I'm going to go back this way. So here's our nice triangular prism. And these sides back here. And we're going to say that this prism is This triangle is an equilateral triangle, so that side's 4, that side's 4, that side's 4, and this piece here is 7. So if we're looking at this prism before we do what we're going to do, what would be the height of this prism? Seven, because I go from one base to the other base, so we're going to say this is a right prism. So from one base to the other base is 7 units. So 7 units is the height. Well, what I'm going to do with this prism is I'm going to open it up. So I'm going to open it up and lay it out flat. So if I do that, my prism ends up looking like this. I have 3 rectangles for the sides, like we talked about before. And I know the drawing isn't perfect, but it'll work. And then we have a triangle that makes up the end of our prism. So if we lay it out flat, we cut it open along the seams and we lay this out flat. We call this a net for our prism when we lay it out flat. Well, on the net, I'm going to label some side lengths. Each side of the triangle is 4. So that's 4, that's 4, that's 4, and that's 4. Well, in order for this to fold up onto the prism, this side has to match this side of the triangle. So that's going to be 4, 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 and this side is right along here. So here are all my dimensions laid out for my net. Well, now in order to find the surface area, all I have to do is find the area of each of these flat pieces. Well, this whole side of this big rectangle is 4 plus 4 plus 4. Well, 4 plus 4 plus 4 is what part of this triangle? Someone said it? That's the perimeter of the triangle. 4 plus 4 plus 4 is the perimeter of the base. And the area of this big rectangle is 7, which is the height of the prism. So the area of this big rectangle is the height times the perimeter. That's going to be the area of this rectangle, because 4 plus 4 plus 4 is the perimeter of the base. And the area of this triangle is B, the area of the base. And the area of this triangle is B, also the area of the base. So the surface area, the total area, is HP plus 2B. So the formula comes from opening up our shape flat and finding the area of each part. If you can't remember the formula, you can't remember how it works, you can always draw a net for your shape and find the area that way. That's a perfectly fine way of finding the surface area of a three-dimensional shape, is drawing a net. It's, for most prisms, not that hard. For pyramids, it can be a really, really nice way to find the surface area. We'll talk about pyramids at the beginning of next week. But we can always unfold our prism, draw the net, and we're just finding the area of each piece, each of these flat pieces, and adding them all together. So that's where our formula comes from. It's opening it up, laying it out flat, and adding up all the areas. All right, questions on that? Okay.